says draw Lewis structures for the following compound/ion. Decide if the compound ion listed can satisfy the octet rule or the duet rule for H, and if so, choose satisfies octet rule. If it cannot satisfy the octet rule, then you either choose too many valence electrons if it's more than 8, too few valence electrons if it's fewer than 8, or odd number of valence electrons. So let's just look at the first one, KrCl2. So to draw the Lewis structure, I usually figure out how many electrons I'm working with in general. So valence electrons, krypton has 8, and then 2 Cls, so 8 plus 14, 22 electrons total that I can work with. So at the very least, everything needs to be connected. So I'll start with this, and we used up 4 electrons, just at the very least connecting them. And then I usually just take anything else and just put it on the board as dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I used up all the available electrons. Now they're all on the board. And looking at this, Cl has 8 electrons, so that's satisfied. This Cl has 8 electrons, so that's satisfied. So since these are full already, we can't really do anything about them. But then you'll notice this krypton here, he's got 10 electrons, so he's a little overloaded. But a lot of compounds that have noble gases, you'll see this happening where they're overloaded, and that is okay. In general, just anything 3rd period and higher can accommodate being overloaded with electrons. So this Lewis structure is correct, but in terms of the octet rule, we call that too many electrons in terms of the octet rule, even though this is the correct Lewis structure. Okay, let's look at PCl3. So P has 5 valence electrons, and then if you have 3 Cls, 3 times 7, so that'll be 26 electrons that we can work with. So at the very least, they need to be connected to each other. Otherwise, there wouldn't even be a Lewis structure. So at the very least, we used up 6 just to connect them. So I have 20 left. So I'm just going to put them down as dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So everything that I could have used, I used up. So now I know anything on this board is an electron that we can use. And then we just check first. So Cl, that's satisfied with 8. This one's satisfied, got 8. This one has 8. Oops. And then this P in the middle, it's got 1, 2, 3, 4, 5, 6, 7, 8. So this one also has 8. So this does satisfy the octet rule. So you would go ahead and select satisfies octet rule. The next one, BH3. So boron has 3 valence electrons, and then the H3, there's 3 of them, they each have 1. So 3 plus 3, we have 6 electrons to work with. So at the very least, you need to connect them to make a molecule. So I'll connect my B with 3 H's, and you'll notice we're already out. So we used up all our electrons. This is what we have to work with. So hydrogen, he's got 2, he's happy. So do these guys. And you'll notice boron, he only has 6. So he doesn't have the octet rule, but we're out of electrons. So this one is going to be too few. And this is the correct Lewis structure. Boron is just one of those elements that he's okay with only 6. But according to the octet rule, there is technically too few valence electrons. The next one, PS3. So P has 5 valence electrons, and then each sulfur has 6. So 5 plus 18 is going to be 23 electrons. So right off the bat, we can see this is an odd number of electrons, so we're never going to have everything perfectly paired. So if you're satisfied, you can stop here and say odd. If you want to know what the Lewis structure would look like, basically it's impossible to get everyone perfectly happy. So if we had like this, at the very least you need to connect them, so I used 6 for that. So that would be 17 electrons. And then I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it looks like he's unhappy still. So we can take these two and move them in between here instead, like that, and then make those a bond. So now 1, 2, 3, 4, he's happy. And now 1, 2, 3, 4, 5, 6, 7, 8, he's happy. 1, 2, 3, 4, 5, 6, 7, 8, he's happy. And then no matter what, there's always going to be someone left out who's kind of unhappy, and that's what happens when you have an odd number. The next one, CCl3. So carbon has 4 valence electrons, and then each Cl has 7. So that's going to be 25 electrons. So again, right off the bat, you can see it's an odd number of electrons. So no matter what, someone is going to be unhappy. So if you're satisfied, you can stop there. But if you want to see what it looks like, at the very least, you have to connect them. So I used up 6 just connecting them. So now I have 19 left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So now you can see he's happy, he's happy, he's happy, and there's always going to be someone just left kind of unhappy. And then finally, NO3 minus. So N has 5 valence electrons, 3 oxygens is going to be 3 times 6, and then that extra minus charge is going to be 1 extra electron. So 6 plus 18 is going to be 24 electrons that we can work with. So at the very least, we need to connect everything. So I used up 6 just to connect them, so I have 18 left. So I'm going to go ahead and just put them around as dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I used up all my 18, so now I know everything from the valence electrons is represented by a dot now at this point. So we can see that N right now is unhappy, so I'm just going to borrow from one of these. I'm going to take these 2 and just move them to in between. So there was 2 there. I'm not creating or destroying any electrons. I'm just moving them from there to here. And when they're in between, that's a bond. So if we look at this, now he's happy. 1, 2, 3, 4, 5, 6, 7, 8. He's happy. He's happy. And now he's happy. And then just one thing to note with Lewis structures for ions, you do have to put them in brackets and add the charge. So everyone does have 8. So this satisfies the octet rule.